Okay, so in the last video we took a look at the approach we're going to take for setting up our belly control system. In this video I'd like to implement everything except for the secondary motion dealing with the chop network. So let's jump over into Houdini. And I'm going to start out by creating a bone. I'm going to create a one bone chain with inverse kinematics. So let me first turn off visibility of our goblin, because if I'm going to point snap I want to keep the view feedback very quick indeed. I'm going to zoom in on the end of the first bone in the spine, activate the bones tool. I'll give this a chain name of belly, and I want to have inverse kinematics on this chain. So I'm then going to go and turn on point snapping and click on the end of that first bone for the spine, and just give Houdini a second to think about that. There we go, turn off point snapping. I can now turn on the visibility of the goblin, switch into wireframe. I want to position the end of this bone down by the belly button for our goblin. So I'm going to click and enter. And that will create our belly root and our belly bone. I'm going to delete the one from the end of those names. So belly root, belly bone. I'm going to name the belly goal. I'm going to rename that to belly aim target. I'm going to jump down inside our Kinchops network, and I'm going to find the newly created belly bone kinematics. And while we're there, let's rename our spine kinematics and our neck kinematics, and then name this to belly kinematics. So rename that to belly kinematics. We can then jump back up to the object level. I'm going to grab the three nodes that got created, our bone, our root, and the aim target. I'm going to move those up towards where we're going to be working in the network. So it's actually going to be up off to the side of the base of our spine, so right around here. Now obviously I want our belly bone to always follow along with the end of the first bone of our spine. So I'm going to take the belly root, and I'm going to parent the belly root into our spine bone 1. Now that should have removed the pre-transform, and indeed it has. I'm going to zero out all of the translations and rotations, since we don't need those in order for the orientation to be successful, since we can see that our bone is still aiming at the end effector. I do of course want to translate based on bone length down to the end of our spine. So I'm going to travel down the length of our first spine bone in the negative Z direction. That will move us down to the end of the bone, so we'll always be positioned there. I am going to deactivate our bones tool as well while we're there. Now we have that in place, I want to create the null that's going to act as averaging the rotations between our first spine bone and our second spine bone. So I'm actually going to branch off of our belly root so that we keep this position, but then I'm going to generate averaged rotations from that position. While we're also here, let's give that a deep yellowy orange, no color, turn off selectability, grab our root, turn off selectability and visibility. I'll leave the aim target visible for now. So I'm going to branch off of our belly root into a new null, and I'm going to rename this null to spine underscore bone 2 underscore average rotations. And to average these rotations, what I want to do is reference the chop data that is being sent to spine bone 2. We know that the rotations are being driven by our inverse kinematics along with the twist that's being applied to that bone, and we want to jump in and grab those rotations from the inverse kinematics, because I don't want to simply look at the orientations and average those, because again we'll get issues where we're going to find the shortest average between these. That would cause this average rotations to flip and snap between certain rotations, and we want to always be averaging the rotation going from our spine bone to the next bone. We know that that rotation of course is driven by the inverse kinematics on that second bone. So if we can look at the rotations that are taking us from our first bone and rotating us round to that second bone, we can then go ahead and average those rotations. To do that, I need to jump down into our chop network. We have our spine kinematics, which is generating information for all of our bones. I want to isolate just the information for bone 2, so I'm going to wire our spine kinematics into a delete chop. and I'm going to rename this to isolate spine bone 2. I'm going to set this to, instead of deleting scope channels, I want to set this to delete non-scope channels. We're going to delete by channel name, and I'm going to delete anything that isn't named with bone 2 in the name. You can see that deleted everything except for our spine bone 2 channels. To make things easier to reference, since we know that this could get the asset names put in front of this. We discussed this back in character rigging 1, whereby if we were inside a subnetwork or inside any other part of the network other than OBJ, we're going to get different names for our bones. In this case, I'm going to take the approach of simply wiring into a rename chop and renaming these to just rotate X, rotate Y, and rotate Z, as opposed to reutilizing that Python expression that we had earlier, which was renaming to spine bone 2, rotate X, etc. So I'm going to wire into a rename chop, and when I mentioned earlier, of course, that was back in character rigging 1, where we're dealing with our FK and IK set up on the ARM. So I'm going to wire into a rename chop, and I'll rename this to spine kinematics rename, and I want to rename from the current names and rename them to rotate X space rotate Y space rotate Z. So now those channels will always be named rotate X, rotate Y, and rotate Z, which means I can reference these and know that they'll always be named that. I will go ahead and wire this into a null, which I'm going to name this null to grab, or even spine kinematics underscore grab values. And again, as mentioned back in character rigging 1, the reason I wired this into a null was a few little issues that I had with referencing chop data using the chop expression when that data was inside an asset. Seemed to be if I reference that data on a null, I would never have any of those issues. So I just use a null to ensure that when I'm grabbing values, I just use a null and reference on the null, and it seems to fix the occasional issue that will crop up referencing chop data inside an asset. So I'm going to jump back up to the object level, and on our average rotations null, so there we go, spine bone 2 average rotations, I'm going to bring up the expression editor for rotate X, and I want to reference that grab rotations chop. So I want to reference inside kin chops, I want to reference our spine kinematics, and that was the spine kinematics grab values, and I want to reference the rotate X channel on that. Of course, I don't want to take the channel as it is. I want to divide that channel by 2, so I only take half of it. That's the whole point of averaging those rotations. I want halfway between our current bone and the rotations being applied to the next bone in line. So I want to divide that by 2. If we accept that, I can then go ahead, copy that expression, paste that, changing that, of course, the channel reference to rotate Y, and for rotate Z. Now the rotate Z, we also need to take into account the twist that's being applied to spine bone 2. So before we divide by 2, since we're going to average the twist as well, I'm going to add onto this that rotate Z of our spine bone 2 twist. So spine underscore bone 2 underscore twist / rotate Z. So that's going to give us the rotate Z of our spine bone 2 twist. Let's just make sure that that did indeed take, and it did. Fantastic. So yeah, we're going to divide our rotate Z, which is our twist, and the rotate Z that's being driven by chops, and divide all of that by 2 to average them. If we accept that, we can now, if we were to, I did put a space in there, so that's probably going to explode. There we go. Now if I was to move our spine, we can take a look at what this null is going to do if Houdini gives me feedback. There we go. So if I grab this control and start manipulating our spine, you can see that null there averaging the rotations, so it is taking some of the rotation from that second bone but not all of the rotation. Fantastic. Let's zero that back to its default location. So we've got the average rotations in place. From here we can create our belly control object. So let's turn off visibility and selectability on that node. Going to wire this into a new null. This will become our belly control. Give this a blue node color, since it is indeed a control object. I'm going to give it a yellow wireframe color. I'm going to give it a control type of circles. Now I want this to only be a circle that sits out in front of the belly of our character. That means I want this to exist on the ZX plane. So I'll set the plane to the ZX plane, and now I can move this and position this in front of our character. So let's translate this down and in front of our character. Something like so will work out nicely. Now I will boost the geoscale, so let's go ahead and boost the geoscale very slightly. And something right around there is going to work fantastically for us. So I can go ahead and clean our transforms. We don't want to allow the animator to translate this on Y. They're going to be limited to X and Z. So I'm going to lock translate Y, lock our rotates, lock our scales, lock our pivot, and lock our uniform scales. So they're restricted to just translating this around, and that's fine because it's all parented in. If we were to say rotate our hips, you'll see that that will cause, of course, the belly control to rotate round with it. Now, of course, the aim target for the belly bone itself isn't moving currently. We'll get to that in a second, but the belly control itself is indeed working. So talking of the belly aim target not moving with the belly control, that's the next thing I'm going to do temporarily, because later on we're going to be intersecting between the belly control and this aim target with some chops data. Keep in position while parenting. I'm going to parent this in to our belly control. And that's going to give us now the ability to come in here with our belly control and start affecting that belly bone, as well as coming in here with our spine controls and also affecting that belly bone, as well as coming in here, and we could rotate the hips, and you'll see that that will take the belly bone with it as well. Or we could come in here, and if we rotate the shoulders, that will apply a small amount of twist to the belly bone. Now currently, and I think the twist will actually demonstrate this perfectly, let's hide our goblin. Notice what our bone is doing in terms of its orientation. We have no twist effector, and its orientation in terms of rotating around Z is going fairly crazy. We can fix this very easily by wiring a node off of our IK handle. Let's hunt down here we go. I'm going to wire a node off of our belly aim target as a twist effector. So I'm going to wire off a new null, and I'll rename this to belly twist effector. If I translate this up in the positive Y direction slightly, that will follow that end effector around and mean our bone will always point up in Y, which will work out fantastically for us. So I'm going to go ahead, turn off the visibility and selectability of both of these. Let's jump down inside our chop network. So hunt down our chop network, jump down inside, and on that spine, or rather on the belly kinematics, let's specify as a twist effector, we hunt down our belly twist effector and accept. So now that's set as a twist effector. If we were to grab the shoulder controls and start rotating these, you'll see that now the orientation of that bone isn't going crazy. Fantastic. So that is going to conclude the this particular video, and in the next video we're going to move on to automating the jiggle using the jiggle chop. But that is going to wrap up this video. Thanks a lot, everyone.